The 3-in-1 Smart Car and IoT Learning Kit from SunFounder is a hands-on, all-included electronics kit that is perfect for anyone who wants to learn how to master the Arduino. The kit comes with an Arduino, 22 different sensors and modules, breadboards, jumper wires, and everything else you need to build a bunch of fun and interesting projects. Learn about robotics by building a remote-controlled smart car that can be controlled with an infrared remote controller, or drive on its own and avoid obstacles or fall on a line. Learn about the Internet of Things with a project that lets you monitor the temperature, humidity, and light level of a room from an app on your smartphone. And build a plant monitor that tracks the temperature, humidity, light intensity, and soil moisture, and displays it on your smartphone so you can keep your plants watered remotely. It's a super cool kit, and I had lots of fun building all the projects in it. So click the link in the description below to order the kit from SunFounder. In this video, I'm going to show you how to control an LED with the Arduino. We'll look at how to make LEDs blink on and off, how to control how fast the LED blinks, and how to control multiple LEDs at the same time. You'll also learn some important programming concepts that will form the base of all the other programming we'll do in this course. LED stands for light emitting diode. Diodes only let electrical current flow in one direction. They're like a one-way valve for electricity. LEDs act the same way. The only difference is that they emit light when current flows through them. Since current can only flow through an LED in one direction, LEDs have polarity. That means they need to be connected the right way around, or they won't work. You probably won't damage the LED if you hook it up wrong, it just won't light up. The side of the LED that connects to the positive voltage is called the anode. The side that connects to ground is called the cathode. You can tell which side is which by looking at the LED. It'll have two wires with different lengths. The longer wire is the anode, and the shorter wire is the cathode. It might also have a flat section on the casing. The side with a flat area is the cathode. The brightness of an LED is determined by how much current is allowed to flow through it. More current makes the LED brighter, and less current makes it dimmer. But there's a limit to how much current can flow through it. LEDs will quickly burn out if you try to send too much current through them. I'll sacrifice this LED to show you what it looks like. I'm connecting it directly to a 9-volt battery. You can see it flash really fast and then blow out. To limit the flow of current, you can put a resistor in series with the LED and the power source. The value of this resistor will affect the brightness of the LED. Higher resistor values restrict the current flow more, so they make the LED dimmer. And lower resistor values allow more current to flow, so the LED will be brighter. I'll provide a document in the resources section that will show you how to calculate the best value of current limiting resistors. But for now, a value between 200 ohms and 1 kilo ohm will be fine. Now let's build this circuit, and then I'll show you how to control this LED in the sketch. Insert your LED into a breadboard, then insert a resistor so that one side connects to the LED's anode. The other side of the resistor connects to digital pin 13 of the Arduino with a jumper wire. Now connect the cathode of the LED to the ground pin of the Arduino with another jumper wire. Okay, that's it. Now let's have a look at the code and get this LED to blink. In the last video, we saw the two functions that are required for every sketch, the setup function and the loop function. We make the setup function by typing void setup with open and close parentheses and open and close curly braces. The loop function is created the same way. To make the LED blink, we need to tell the Arduino which pin the LED is connected to. We also need to tell it whether that pin will be an input or an output. To do that, we use the pin mode function. This pin is not going to change throughout the program, so we put this code in the setup function. Remember that the code in the setup function is only run once when the program starts. The pin mode function needs two pieces of information: the pin number and the input-output mode. These are called arguments of the function. The first argument is the pin number, and the second argument is the input or output mode. We've connected the LED to pin 13, so I'll type 13 here. Then I need a comma to separate the arguments. Since we want to send current to the LED to make it light up, the pin will be an output. So I'll enter output to set the pin mode as an output. If we were using this pin to detect a signal instead of sending one, we would type input. This all needs to be in uppercase. All of the code in the Arduino is case sensitive. Finally, we finish off the function by putting a semicolon after it. Pretty much every function needs a semicolon after it. There are some exceptions, but for the most part, it needs to be there. That's all the code we need for the setup function. The code we write in the loop section is going to get executed over and over again in a loop. Let's think about what we want to do here. We want to make the LED connected to pin 13 blink on and off. To turn the LED on, we need to send electric current to it. All of the Arduino's digital pins can either output current or detect current. To output current, we use a function called digital write. The digital write function needs two arguments: the pin number you want to control, and whether that pin should be high or low. High means the pin will be switched to a high voltage state. In the case of the Arduino, a high voltage level is 5 volts. Low means the pin will be switched to a low voltage state, which is 0 volts or off. In the digital write function, the pin number goes first, followed by comma, then either high or low. We want to turn the LED on, so we need to write a high voltage to the pin. This all needs to be in uppercase too. Next, we need to tell the Arduino how long we want the high signal to be on. We do that with the delay function. The delay function tells the Arduino to pause and wait before going to the next line of code. The number inside the parentheses is the delay time in milliseconds. Let's make this LED blink on and off every half second. There are 1000 milliseconds in 1 second, so to keep the LED on for half a second, you would put a 500 in here. Now we need to turn the LED off, so we use the digital write function again, except now instead of sending a high signal to pin 13, we send a low signal. Next, we need to tell the Arduino how long we want to keep pin 13 low, so we use the delay function again. So let's see what's going to happen in this sketch before we upload it to the board. The Arduino is going to start at the top and work its way down line by line. First, it encounters the setup function, where we set digital pin 13 as an output. After executing the code in the setup section, it continues on to the loop function. In the loop section, we send a high voltage signal to pin 13, then delay for 500 milliseconds, then we send a low signal to pin 13, and delay for another 500 milliseconds. After executing all this code, the Arduino goes back to the top of the loop section and executes it again and again. The code in the loop function will be run over and over until you turn off the power or upload a new sketch. Let's upload this to the Arduino now. The IDE verifies the sketch and compiles it. It didn't find any errors, so now it's uploading the compiled sketch. so it looks like the code is working as expected. If you want to change how long the LED stays on, just change the delay time after pin 13 is written high. Let's upload this. You can change how long the LED stays off by changing the delay after pin 13 is written low. Why don't we add another LED to the circuit? Let's add a green LED to go with the red LED. Both LEDs need to connect to ground, so I'll use the breadboard's negative power rail. I have a jumper wire connecting the ground pin of the Arduino to the negative power rail of the breadboard. The cathodes of the LED are connected to the negative power rail. Then, each anode is connected to a current limiting resistor that connects to the digital pins. The red LED can stay connected to pin 13. The green LED will connect to digital pin 2. To program two LEDs, we can basically just duplicate the code for a single LED and change the pin numbers to pin 2. I'll upload this. Alright, so it works. Both LEDs are blinking on and off. Now looking at this sketch, it's not very obvious which pin is driving the green LED and which one's driving the red LED. To make it a bit easier to understand, let's create a couple variables to store the pin numbers. Then use the variables instead of pin numbers. I won't go too in-depth into variables right now because I'll explain more about them in another lecture. But for now, just think of variables as containers. Containers that can store values. In this case, the values will be the LED pin numbers. Using variables, we can change out the pin numbers with a descriptive name that will help us understand what's going on in the code. It'll also be easier to change the pin numbers in the future. To create a variable, go up to the top of the sketch and type int for int. Int sets the variable type as an integer. We'll explore data types in a lot more detail in a coming lecture too, but for now let's just see how this works. Then we type the name of the variable. But I think a good name would be red LED for the red LED. Now we set the variable equal to the pin number that the red LED is connected to, which is pin 13. And we end with a semicolon. Creating a variable is technically called declaring a variable in programming terminology. Let's declare a variable for the green LED too. I'll call it green LED and set it equal to pin 2. Now, every place the program sees the text green LED, it'll be replaced with the number 2. And everywhere it sees the text red LED, it'll be replaced with the number 13. Let's go down to the setup function where we define the pins as outputs. Since the number 13 is now stored in the red LED variable, we can change this to red LED. And the number 2 is stored in the green LED variable, so we can change this to green LED. We can also change the pin numbers in the digital write functions to our pin variables. Now it's a lot easier to see what's happening in this sketch. So now you know how to use the Arduino to turn LEDs on and off. Now we can take it one step further and control the LED's brightness. In the next video, We're going to use pulse width modulation to control the brightness of an LED with code. SunFounder is my go-to source for sensors, modules, and other parts for the Arduino and Raspberry Pi. They have a huge selection of STEM, robotics, and IoT kits, and lots of useful sensors and modules. Every product has an online tutorial with wiring diagrams and example code. They also offer free shipping on all orders, with no minimum. Give them a try at www.sunfounder.com next time you need to order some parts.